Have you ever looked up at the night sky and wondered, will this all last forever? It's a question that has captivated humanity for centuries. We know how the universe began with the Big Bang, but how will it all end? Today, we're diving deep into the most mind-bending theories about the ultimate fate of our cosmos. So, buckle up, because we're about to journey to the very end of time. First, let's talk about the force that governs everything on a grand scale. Gravity versus dark energy. Think of it as a cosmic tug-of-war. Gravity, the force that pulls galaxies together, is constantly battling dark energy, a mysterious force that's pushing everything apart, causing the universe to expand at an accelerating rate. The winner of this epic struggle will determine how our universe meets its end. One of the earliest and most dramatic theories is the Big Crunch. Imagine the expansion of the universe slowing down, stopping, and then reversing. If gravity were to win the cosmic tug-of-war, everything would start pulling back together. Galaxies, stars, planets, everything would race towards a single, infinitesimally small, hot, and dense point. Much like the conditions before the Big Bang, it would be a cosmic recycling event, a fiery collapse into a singularity. Some physicists even theorize that this could lead to a big bounce, where a new universe is born from the ashes of the old one, creating an endless cycle of expansion and contraction. It's a spectacular idea, but current observations suggest the universe's expansion is speeding up, not slowing down, making the Big Crunch seem less likely for now. So, if expansion is accelerating, what does that mean for us? This brings us to a far more violent and spectacular end, the Big Rip. In this scenario, dark energy doesn't just win, it becomes overwhelmingly powerful. The expansion accelerates so ferociously that it overcomes all other forces. First, galaxy clusters would be torn apart. Then, the gravitational glue holding individual galaxies together would fail, and stars would be flung into the void. The terrifying part is that this tearing doesn't stop. Solar systems would disintegrate. Planets, including our own Earth, would be ripped apart. Eventually, even the atoms that make up our bodies would be shredded into their fundamental particles. In the final moments, space-time itself would be torn asunder. The Big Rip is a truly cataclysmic end, a complete and total annihilation. But what if the cosmic tug-of-war ends not with a bang, but with a whimper? This leads us to the most widely accepted theory among physicists today, the heat death of the universe, also known as the Big Freeze or the Big Chill. This is a much slower, quieter, and perhaps more melancholic fate. In this scenario, the universe continues to expand forever. As it expands, everything gets further and further apart. The universe becomes colder, darker, and emptier. Over trillions of years, all the stars will burn out, one by one, leaving behind black holes, neutron stars, and cold remnants. The last lights of the cosmos will flicker and die. The era of stars will give way to the era of degeneration. Even these stellar remnants will eventually decay. Protons themselves might decay, dissolving all matter as we know it. The only things left will be black holes. But even black holes aren't eternal. Thanks to a process called Hawking radiation, they slowly evaporate over unimaginable timescales. We're talking trillions upon trillions of years. The largest black holes will be the last structures to disappear. After they're gone, the universe will be a vast, dark, and empty void, filled only with a sparse soup of photons and elementary particles. It will be a state of maximum entropy, where no work can be done, no life can exist, and no events can happen. Time itself would lose its meaning. It would be an eternal, silent night. So, which fate awaits us? The fiery Big Crunch, the violent Big Rip, or the cold and lonely heat death? Current evidence, like the accelerating expansion of the universe, strongly points towards heat death. But the nature of dark energy is still one of the biggest mysteries in science. If its properties change over time, the Big Rip could still be on the table. We live in an incredibly special time in the universe's history, a brief moment of warmth and light between the initial fireball of the Big Bang and the eventual cold darkness. Thinking about the end of the universe can feel overwhelming, but it's also a profound reminder of the scale and wonder of the cosmos. It pushes us to ask the biggest questions and to appreciate the fleeting, beautiful moment we have right here, right now. It inspires us to keep exploring, to keep learning, and to cherish our tiny, vibrant corner of this vast, mysterious existence. The quest to understand our ultimate destiny is one of the greatest adventures in human history. Thank you so much for joining me on this journey to the end of time. What do you think is the most likely fate of the universe? Let me know in the comments below. If you enjoyed this cosmic exploration, please hit that like button. And don't forget to subscribe and turn on notifications so you don't miss our next adventure into the mysteries of science. Until next time, stay curious.